In this video, we're going to be doing some linear momentum practice. Linear momentum, or momentum, is when you have mass in motion. So let's start off with our first question. A 2 kilogram car moving at 3 meters per second to the right. So you have a car, we're going to the right. And this is 2 kilograms. And it collides elastically with a 1 kilogram car that is at rest. What is the final velocity of the 2 kilogram car? So you have to use inelastic collisions. When you have inelastic collisions, you have now you just plug in your values. So M1 is 2 kilograms, M2 is 1 kilogram, divided by their combined mass. Then you multiply it by their initial speed, 3, and then you add it to 2 times the second mass, which is 1, divided by the combined mass again, times the second object speed, which is our object at rest. And if you plug this in, you're going to get 1 over 3 times 3.0, which is 1.0 meters per second. And because we got a positive answer, this is going to be right based off the coordinate system we've been using in this question. So your answer is A. A 0.5 kilogram ball is moving at 8 meters per second and strikes a wall and rebounds with a velocity of 6 meters per second in the opposite direction. What is the magnitude of impulse delivered to the ball? And you're gonna hit the wall. After that, you're gonna rebound and go the opposite direction. So that means that you have a force that is the wall is exerting on the ball that is pushing the ball back the other way. So mass is 0.5 kilograms. V initial is 8 meters per second. VF is negative 6.0 meters per second because you go the other way. So we can see the speed got smaller after you hit against the wall. You can use the impulse momentum theorem. Impulse is equal to the change in momentum. Momentum is equal to m times v, but we want change in v here. You can rewrite change of v as v final minus v initial. So J is going to equal to your mass, 0.5, times negative 6.0 minus 8.0. That is equal to negative 7.0 newtons times seconds. But you want the absolute value. So that's going to be 7.0 newtons times seconds, because that's what our options here. And we want the magnitude. Magnitude has no direction, no negative or positive sign. 2 objects collide and stick together. Object A, mass of 3 kilograms, moves 4 meters to the right. So this object is going to the right. and it's traveling at 4 meters per second. And then object B is going to be a mass of 2 kilograms, and it is traveling at 2 meters per second. So what is the final velocity of these objects? We can use conservation of momentum. So you have M initial, or M1, V1, we'll say MA, VA, plus M2, or MB, VB, and we can mark these as initials. So your mass will always stay the same, but your velocity, this is going to be your initial velocity, and this is going to be your initial velocity, times the same masses, but now it's one object, and because they stick together, this is perfectly inelastic. And also, a note about conservation of momentum, you are going to use this with all collisions because all collisions are going to conserve momentum. So that's VF. You're going to have 3 times 4 plus 2 times negative 2 is equal to 5 times VF. That's going to be 12 minus 4 is equal to 5 VF. 8 is equal to VF, and divide both sides by 5. VF is equal to 1.6 meters per second. Because you have a positive 1.6 meters per second, this is going to be to the right. A rocket in deep space ejects gas at a constant rate. What statement best explains why the rocket accelerates? So we know that if the rocket is ejecting gas, that means that it's pushing the mass backward. So you have a rocket, and it's going to be pushing gas out this way. So then there's going to be an equal and opposite force that is going to push the rocket this way. So you need to know that your total momentum is going to be conserved. So the gas, it's gonna gain a backward momentum, and your rocket is going to gain a forward momentum. Momentum is when you have mass in motion, and this mass is in motion. So you have no external forces, which is why you have conservation of momentum. That means that your momentum of your system stays constant. So the reason why the rocket accelerates is because the momentum, it has to be conserved. It's the same. So if you push your gas this way, then you have to have the same movement forward, because that movement, that velocity has to be transferred. A 1,000 kilogram car moving at 20 meters per second collides head-on with a 1,500 kilogram truck moving at 10 meters per second in the opposite direction. And you have a, so that's a 1,500 kilogram, we'll call this M1, and this is V1, and this is M2. This is going to be V2, and this is 10 meters per second. So we want to know if they stick together, That means you have a perfectly inelastic collision. We want their final velocity. So we have conservation of momentum. You have m1 plus m1 times v1 plus m2 v2. So this side is your initial side. We're going to just call this your initial side so we don't have to label the variables that. And then this side is final. So this is going to be m1 plus m2 vf because it's one mass now. So this is your initial state. But then once they stick together, it's going to be one combined mass. So in their final state, it's going to be m1 plus m2, which is why you have to add those two. Now all we do is we just plug in our values. So m1 was 1000, then m2, then the velocity of that was 20, then m2 is 1500, and the velocity of that is -10 because you're moving in the negative direction here, and we have our coordinate system. If we make the right side positive, that means that the left side is going to be movement in the negative direction, and we have no vertical movement here, but this is how we were defining our y-axis. So here, this is going to be equal to, our combined mass is going to be 2,500 because this is equal to 1,000 plus 1,500. So because it's positive, this means that it's going to go in the car's original direction. Note that this is our car and this is our truck. So it's still going, our combined mass is still going to end up going in the direction the car was going. And this final speed of the combined mass is 2.0 meters per second. A 0.2 kilogram puck slides with a velocity of 5 meters per second and is struck by a stick, reversing its direction with a speed of 7.0 meters per second. And if the contact time is 0.10 seconds, then what is the average force? So here we have given 0.2 kilograms. So and there's a stick right here, and then it will go back at a velocity of 7.0 meters per second. So when it is at this contact point, we want to find what the average force was. In this case, you can use the impulse momentum theorem. So you have your F average is equal to the change in momentum over the change in time. Change in momentum is mass times the change in velocity. And you can expand that to Vf minus V initial. So your mass is going to be 0.2. It's already in SI units. And you have negative 7.0 meters per second. We should actually mark this as Vf negative 7 because it's moving in the negative direction, because we're going to find positive x to be that way and positive y to be up. So that's 7.0 minus 5.0 divided by divided by 0.010. So that's equal to negative 240 newtons. But if we want the magnitude of that, we just look at the number. That's 240 newtons. A 60 kilogram skater at rest pushes off a wall and moves 3.0 meters per second. What is the velocity of the wall after the interaction? So this is our wall, and skater is standing like this, and then after this, the skater is going to push off of it and then have a velocity. So then the wall pushes back with a force, so then she's gonna move in this direction. I'll say she's moving in this direction. So you have conservation of momentum here. So your initial is equal to your final. So, but your initial here is 0 because she starts at rest and then she starts to move with a velocity. So let's write out the P for each of the objects in the system. So in the system, we have the wall, and we also have her. So we have skater. And here we have wall, and we have the skater. We already know that in the beginning there is no momentum, but in the end there is going to be momentum, and we have to do the momentum for each of the objects. Momentum is equal to mass times velocity, so you write that out for each. And then you divide both sides by V wall. So we know that the wall has a very large mass. So we say that the velocity of the wall is approximately going to be 0. So we say that the wall technically moves, but it's going to be effectively 0. Two identical masses collide. One is initially moving and the other one is at rest. After an elastic collision, what happens? In elastic collisions, the objects are going to exchange velocities because you have momentum and also kinetic energy that is conserved. So the only option is that the moving object stops and your stationary object takes its velocity. A 5 kilogram object moving at 6 meters per second experiences a constant force for 2 seconds and ends at 2 meters per second in the same direction. So then we have a force and then after that you still have the same mass, but it's still acting at a velocity of 2 meters per second. So we know the force is equal to change in P over change in time. That's equal to M change in V over change in time, and that is equal to M VF minus V initial over change in time. So it's still going to be moving in the same direction. So these are both positive still. And we're talking in a time interval of 2 seconds. So that force is negative 10 newtons. The reason why it's negative is it's going to be a force that is opposing motion. So it's going to be slowing the object down. That's why you have the negative sign. So the answer is A. A system has 0 net external force. Which statement must be true? So we know that. So if we know that that is equal to 0, then you can replace this so you have a constant momentum. And also this is the definition of what conservation of momentum means. You have no external force, that means you have constant momentum. So what's allowed when you have constant momentum, conservation of momentum? Is that your velocity can change internally and your system momentum can stay constant.